So we'll talk about Linux processes today. Because Linux is a multi-user environment, right? Some users can use that system simultaneously as well as running their own set of programs, right? Which means multiple users can be using or running the same program all at the same time, right? Um, so that's what a multitasking environment provides, right? So each of those instances of those running process would have their own individual ID, right? So an instance of a running program is referred to as a process, right? So each process is unique, it has a unique ID, except for the init, which is predetermined, the page value of 1, right? So other processes, as they're generated, right? So every instance gets their own unique ID, right? So same process could be running multiple times with different IDs, right? Because they may be associated with a different user. So from a shell, in other words, from the terminal, you can manage these processes. You can start them, you can pause them, you can kill them. So they're obviously based on the use case or the situation. It may be necessary to kill the process sometimes, or if it's hung, right, maybe you need to restart, or maybe it's consuming too much resources, such as CPU or RAM. So sometimes it is essential to restart, kill a single or multiple processes. So we have some utilities to manage and to manage these processes. So that includes PS, FG, the top command, kill, and the jobs. So these utilities, right, are kind of similar to the task manager in Windows, right? So in the task manager, you see all the currently running processes, their association with the user, and their unique ID, right? So that ID is used to either kill, restart that specific process. I mean, these are just a few of many more utilities that we can leverage to manage processes. So as mentioned, right? So VI is just one command, one editor, but it can be used by multiple users simultaneously. So again, each of them would have their unique ID, even though it's the same program. Right? So processes running as root will obviously have more privileges because, as we know, right, the root user has all the privileges on that particular system. So anything that the root user does is run with much higher privilege than a regular user. So in Linux, right, these processes are actually can be found in the proc folder, right? So that in the proc folder, what you'd see is a bunch of folders with a bunch of numbers, right? So these numbers are actually associated with the specific process, right? So how does the system determine, right? Is the system randomly or automatically assigns these process IDs as they are created, terminated, and whatnot, right? So the system handles that, and in the proc directory, there'll be another associated folder with that particular ID, right? So if you were to run the top command, right, in the top command you'd see PID values, right? So if you then browse into the proc folder, what you see is a bunch of folders with those PID values. So here's this screen cap of the proc directory, right? And on the right hand side, I actually browsed into folder number 10, right? So in there, you see a bunch of other files and directories that are associated with this particular process, which has the PID value of 10. So obviously these changes dynamically as, again, processes are created, terminated. So let's actually quickly log into my system so we can see this live. So I'm logging into my system. Okay, so I'm in. I'm going to elevate my privilege. Okay, there we go. So I am now a root user, right? You can tell by looking at this, right? So before I had that prompt, the regular user, the $, now I'm the root user. Okay, so I'm going to go into the proc folder. So let's do that. Now I'm in the root, and then I'm going to proc folder. Okay. And so before I browse there, let me quickly run the top command. Okay, so that is the top command, and this is the PI. These are the PIDs that I mentioned earlier, right? That PID, the very first column, right? So you see a bunch of numbers there, right? So each of them is associated with a specific process, right? So for example, 21 is associated with write back command, right? So as more processes are created, you can see the associated user, right? Who created them or who's using it, and a bunch of other properties there too. So when you browse into the proc directory, right, you see a folder with these numbers. So let's pick number 14. 17, either one. So I'm going to go back, let's quit, and ls. So here it is. So you can see a bunch of folders there with numbers, right? So these are associated with the process ID that we just looked at, right? So when you run the top command in general, right? So this is just a sample. This is obviously not the entire list of all the processes, right? Let's go back. So let's browse into 17. Okay, so now I'm in folder number 17, and let's look at the content. How about this value? Okay, here we go. So in here you see a bunch of files, mainly files, a couple of directories, right? So directories and files. Okay, so I'm going to exit out of here, and I'm going to go to another folder. Let's go to, I don't know, 20. Okay, so 20. Okay, so now I'm in 20, and let's have a look here too. So again, mainly files, a couple of directories there. So what this is showing me is the content of that folder number 20, right? So these are files and directories that are associated with the PID value of 20. Okay, so 20 was this. So these are you could find these under the proc folder. So then we can use process status command. Is a small utility. It's called process status, PS. So that's also very handy. It also organizes the it presents the information in columns, right? So here's a sample output of this very simple command, psu, ps space u, right? So what I'm seeing here is two processes, right? The first one has the PID value of 2147, and the second has the value of 2310, right? So next time, let's say Jake logs in at a different time and runs the same exact command, right? So that PID value could be different at that time, right? So this is not, so for example, bash is not always PID does not always have the PID value of 2147. It could be 22 something, right? so these are again assigned by the OS at that moment, right? Okay, so what's important here is that so when Jake logged in the first time, right, he ran this command, the bash command, right? And then he also ran that psu command. Okay, so this is the user who ran it, and this is the process ID associated with that particular command. And we can also see the utilization of that process, right? So as mentioned earlier, right, sometimes processes can take up more resources than they should, right? Sometimes some processes take up 90%, 99% of the CPU, and that's bad in terms of performance, right? Because that means other processes are not getting their proper resources, right? So that's one example of when you might want to kill this particular process so that the system is normal again. So similar thing that can also happen with memory, in terms of memory also, right? Sometimes they take up more memory than they should, so you need to either terminate, kill it, and whatnot. So some columns here, right? The PID values, CPU and memory utilization, the VSZ and the RSS corresponds to the size in memory. The TTY column shows the terminal type that the user is logged into. Some other interesting stats: the start time, and lastly the command itself, right? So let's run this on my system. Right, so mine is a very simple system. I don't have a whole lot going on, so it's rather limited, but you get to see the same thing, right? The user, right, who's doing it, the process ID, right, and how much their in terms of what their utilization rate is, right, and the time and the date. So interestingly, if this was from a previous date, you simply see the date, and if it's today, you see the actual time and the command. Okay. So some other variations of the PS command, right? So the PS is very useful. So let's run this. Let me run it this way first. So I simply run PS space UX. So that will show me the processes of the current user, right? So I'm logged in as root, right? So I'll see all the associated processes for the root user. So as you can see, there's a lot of information there, right? And I have to scroll through, right? I may or may not want that, right? So I'm going to just type it with the less command, right? So that that will give me one page at a time, right? So it's more easier to handle, right? Easier to look through, and I simply press the space bar to go to the load more output from the command. So again, it is the same exact output, except it's presenting in a more rather condensed manner, so I can easily sift through the information there. So the less command, right? It's not specific to process status, right? So the less command, this part, less can be used with combined with other commands as well, right? So after the end of the command, you simply add a vertical sign and then the word less. So this is similar to the way we use grep also. So grep is used for searching. Okay. So let's say I want to see processes for all the users, right? So that would be X less. Okay. So now I'm seeing the processes for all the users. Now as I mentioned, my system is relatively small, right? And I'm really the only one who's currently logged in, right? So even though whether I run this command or this command, I'm only going to see the root because there is no other user at this moment, right? But if you had a multi-user system, which is actively being used, when you run the second command, right, you can expect to see, yourself and maybe a bunch of other users and their processes. Now remember, man is our friend, right? When you need help, you ask the man, right? So man ps. So what you're seeing here is obviously the detailed manual page for the ps command. So man is very detailed, right? Pages of detailed and very thorough explanation of the command, the syntax, and examples. Now sometimes you can use the help command also, right? The help command is not always present, right? So you have to simply try it and see if it's there. So the difference between the help command and the man pages is that man pages is the most extensive documentation. The help is rather simplified version of that, right? It's to the point, minimal, right? It is worth looking for, right? So the syntax for that is man dash dash help. Okay. So for the process status in particular, right? There's another parameter that I have to add is all, right? So this is this part, that all part is not required for all the other processes, right? So, but for this particular one, it is, right? So as you can see, right, this is a much more simplified, easier to read version of the man pages, right? Very simple, easy to read. So there are two ways to get help, right? One is using the help, right? And the other is the man pages, of course. Man pages are there for nearly all the commands. The help content varies. It is there for majority of the commands, but not all. So you can see some variations of the process status command, right? So you can specify what you want to see, which column, right? You can sort them. So these columns are similar to this. So you can sort them. You can specify what you want to see. Right? So we're going to go back to the top command, right? So before we move on, so when you run the top command, right, this is a sample of that. You'd see a bunch of columns, right? And this is what they refer to, right? The PID, user, the PR, the time, command, etc. So these commands, the top command would show you all of this. Now the top, there are a couple of lines there, so that is showing you the overall utilization of that system. So let's run the top command and analyze. Okay, so I'm running the top command now, right? This part right here is the overall system utilization, right? So I see the CPU utilization there, memory usage, right? How many tasks are running, how many sleeping, and how many active, right? So as you can see, this is not a very active system, right? It's a relatively low key system. So again, the columns that we talked about. So the top command, right, it's similar to Windows Task Manager, except it runs on the terminal, right? And there are two other commands, nice and renice. So the purpose of nice and renice is that sometimes some processes need more resources, right? So we can, depending on the process, we can use those commands to give a certain process more resources because they may be running an important application on that system, right? So we can leverage that command. So similar to the PS space U output, right? There's a bunch of columns and what it means, right? How to interpret the output of the top command, right? What are you looking at? So within the top command, right? So right now I'm running the top command, right? So within the top command, there are other sub commands that I can run, but let's see what they are first, right? So after running the top command, I simply press H, right? So that shows me this miniature help menu for that is specific to the top command. Right? So this is these syntaxes are only, these parameters are only applicable to the top command, right? So I need to go back to the top output. I'll press the Q or escape, right? So I'm going to press the C quickly. So notice that as I'm pressing the C key, right, the output is changing, right? What about the M key, right? So that's a visual change right there in terms of the memory, right? So as I press the M key, right, it's changing the output, right? Okay, and if you want to go back and see additional information, simply press the H key, look for the particular thing, and then or particular letter, right? And then simply go back and press those keys. So this is, so you're still within the top command, right? And when you're done with all of that, you simply press the Q to exit out of top. Okay, so then now you're back in the prompt. So lots of options here. These are commands that you'd run into within the top command, right? So always look for press the H key to get the help, and then go back and run the particular letter, right? So top is excellent, right? So top is what's built into nearly all the Linux system, right? It's very pretty much built in to all Linux system. There are some additional tools that we can also use to get information and manage the processes. So for example, we have something called htop, right? So the layout is very similar to the top, right? Except this is somewhat more enhanced, right? So if you look at the bottom, it's menu driven. The visual looks more appealing, right? The organization of the content is a bit more appealing, right? Again, the htop is not usually built in, right? So you have to run yum install htop. So on my particular system, it is already installed. But if you run htop and there's no output, or there's there's an error, you'd have to run yum install htop. Right? So this will tell me I already have this installed, right? There's another one, nmon, which is also pretty nice, right? This is also menu driven. So if I run this, right, so as you can see, and then you have to press the specific letter. How about C? Okay, so now I'm looking at the CPU utilization, right? What about network? Okay. So this updates in real time, right? So this is pretty neat. Again, you can see the utilization of different resources. I think there's another good one. It's vtop. No, is it atop? There you go. Very similar to the top output, right, or the htop. just being presented in a different manner, right? So it depends on what you're looking for, but essentially you're looking at the same set of information, really, but just presented differently in different columns, right? Let's get out of there. So vtop was another command actually, but I just don't have that installed. So some of these utilities are, right, ptop, vtop, sar, right, nmon. So again, these may or may not be included with your distribution, right? So typically these are, you have to proactively install them, right? Yum install for Red Hat based system, or if you have Debian or Ubuntu based one, you'd use apt-get install, and then so for example install nmon, something like that. So that's for Debian or Ubuntu based. I'm using a Red Hat based, so I have to use yum install nmon. Okay. So these, think of these as the enhanced version of the top command, right? So top is rather basic, but still very functional, and it's built into nearly all the Linux systems. So in Linux, right, we can manage the processes on the background and foreground. So oftentimes, right, if you run sophisticated commands that is expected to take long, you can move back and forth between foreground and background, right, so that you can move on with other things, right? So let that command run and process, because it will take 5 minutes, 10 minutes, whatever, and then you can continue to work on other things. So you have the flexibility, right? You don't have to necessarily wait until it's finished. So here's an example of that, right? And the way we do this is by adding the ampersand sign at the end, right? So that's telling the system to move the process in the background or foreground, right? So it starts a job. Right, so if you run the jobs command, that would list all the jobs that are currently valid, right? So the status is there also, right? So let's look at my system here to see if it's running anything. No output, right? So that means nothing really is running. So I'm going to start something, right? So how about this? I'll run the same one. And okay. So I have let's see. Right, so I had to run this command quick. So as you can see, as soon as I issued that command, right, it created a job with a number, with an ID, unique ID, right? And then when I run the jobs command to list all of them, you notice the status was done rather quickly. So this was a very simple command to run, right? And pretty much literally in a couple of seconds it was done. So if I rerun the jobs command again, because it's done, it's no longer there, right? It's finished. So in this example, however, because these are more, somewhat more complex commands, right? So these might take a while to either finish or in this particular example, right, I see five jobs with different status, right? So we can move back and forth between the foreground and background, right? So we use the FG for foreground and BG for background. Okay, so this is the syntax, right? You'd FG space percentage and then the associated number. So what this does, it essentially restarts the Y editor, right, and edits that particular file, right? So if you run this, it opens the my file in the Y editor. Likewise, if you run the bg on 5, right, bg space percentage and 5, right, this job will restart. And then after running this, if you went back and checked the jobs command, this status would change, right? It'll from stop, it will be running. So you'd use this to your advantage as needed. So you can often issue the jobs command, take a look, to see what's running, what's stopped, and use the foreground or background as necessary, right? No jobs, right? So again, this is a rather simple system, so nothing exciting going on. So sometimes processes take up more resources than they should, right? So there are two ways we can terminate, right? Two commands, kill or kill all. So generally kill is used with a specific process, right? So you specify the PID value, and the kill all is generally used to kill multiple processes that have a similar name or a specific name, right? Remember, multiple users can be using the same process all at the same time, right? So kill all and kill are slightly different, but the intention is really the same. So different processes respond to different signals, right? So the common ones are sig kill, sig term, and sci up. So sig kill, they really processes cannot really ignore that. That's forceful, the sig kill. The sig term is more graceful because it gives the processes to terminate their own threads internally more gracefully, right, and then terminate themselves, right? So this is sort of telling the program to gracefully or peacefully, right, terminate themselves. The sig kill doesn't take really anything into consideration. It simply kills the process. So generally, it's better to try the sig term first. If that fails, then go for sig kill, because that's sig term is cleaner, right? It's more graceful. So how how to use the sig the kill or kill all, right? So again, you'd run the top command, find out the PID value, right? So in this sample here, we can see that this particular PID, right, that Chris is running, is consuming a lot of CPU power, right? And this is the command associated with it. So we want to kill it, right? So so you issue that command, kill that PID, and because this is a very specific PID, right? Now, what if you wanted to match a naming condition, right? You use a specific name. So in that instance, you use the kill all, right? So the kill all kills multiple processes by name instead of PID. So the nice and renice commands are used to give some processes some extra privileges. Again, the purpose is to allow certain processes to leverage more resources, right? So every process has a value between -20 and 19, and the default value is 0. The lower the nice value, the more access to the CPU the process has, right? As an ordinary user, it can only set between 0 and 19, right? And on your own processes, the root user, right, because the root user is the privileged one, they can set the value as long as it's within the valid range. And here's how to use this, right? So you issue that nice command, add the value, specific value, and for the process, right? So when you run the top command, right, you can see the nice value there, the ni column, right? So it's a small utility to from time to time there might be a need to allow certain processes to take more advantage of the CPU. So you can do that, and when you're done, you can simply remove that and go back to the default, right? So you use the renice command. So that brings us to the control groups, right? So the purpose of control groups is similar to the nice command, right? So with the C groups, right, what we're essentially defining is the parameters of CPU, memory, disk I/O, network, so that certain processes can take advantage of them, right? This is done in order to improve the performance, because they may be running an important application, or these processes require more system resources, right? So as such, you can define who's entitled to what, right? So that is the purpose of a control group, so that certain processes are treated as VIP because they are entitled to use more resources of that system. So as the processes created, right, or they're launched, sometimes they would create child processes, right? So real quick, these child process, the reason why it is recommended to use sig term here is because of these so-called child processes. When you use sig kill, it kills the parent, right, without taking into consideration about the child processes. The sig term, on the other hand, gracefully terminates the child first, and then and the parent. And it sounds morbid, but it's cleaner, at least in terms of Linux systems. So it is better to use the sig term instead of sig kill. So going back to control groups, so when you create control groups, right, these child processes are also able to take advantage of the entitlement, right, of the dedicated resources. So it does improve performance of that system. So again, man is our friend, right? So always take advantage of man. Okay. So using the C groups, right, these are some of the parameters that can be defined, right? So the mainly CPU, memory, right, network capability, and there's a few others too, right? So you can sort of define what processes are entitled to take advantage of these resources, because at any given system, right, resources are shared, right? With C groups, right, you can actually dedicate or reserve, so to speak, a certain portion for certain processes because they are critical for that server. So there's a bit of setup involved with this, right? You'd have to define all the parameters and then associate with the processes,